In the diagram below, what is the relationship between the number of triangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and graph. All right, so first we want to think about the fact that the input is going to be the number of triangles, and the output will be the perimeter of the shape that those triangles create. So if we look at the first image, there's one triangle, and notice that the perimeter is 4 plus 3 plus 3, or 10. If we look at the second figure, there are two triangles. There's the 4 plus 3 plus 3, which is 10, but now there's an extra 4, so the perimeter is 14. Looking at the next figure, we have the two 3's, the original 4, the 4 from last time, but we have an extra 4, so we're at 18 for a perimeter of a figure with 3 triangles. If you look at that again, notice we still have those 3's on the side. We have the 3 4's we already talked about. We're getting one more 4. So we can start to realize as we look at this that we're adding 4 every time as we add another triangle, but nothing else is changing. So if we try to put the pattern into words, we might say something like, we start with 10 as the perimeter, and each triangle adds 4 to the perimeter. But when we get an equation, we have to think about this. There's a few different ways we could write an equation. One way is to think about the words we just said. We could say that the perimeter equals the 10 from the first triangle plus, now for each additional triangle, we're getting 4 more. So it's going to be 4 times something. But notice we add 4 on the second triangle. So we're adding 4 to the number of triangles minus 1. Because if you look at this third one, that's the third triangle, but we're only adding 2 4's. So 3 minus 1 is 2, so 2 times 4 is 8 for how much we're adding. Now, that might be how we build up our formula, but it would be ideal if we didn't have such a long formula. So let's try distributing that 4. That gives us P equals 10 plus 4n minus 4. Well, if I simplify a little more, the 10 and the negative 4 are like terms. So I have 6 plus 4n. So 4 times the number of triangles plus 6 will equal the perimeter. And if we look at that, notice there's 1 4 for the first triangle and the 6. Each of these pictures has that same 6. There's the 6, there's the 6, there's the 6. One triangle has 1 4, 2 triangles has 2 4's. So that's another way we might have thought about the problem. It's possible that someone else looking at this problem, when they put into the words, they might have said the number of triangles times 4 is added to 6 from the two sides. So there might have been more than one way to use words to describe this pattern. When we go to make the graph is based on the table. Again, kind of like in the previous problem, I don't have 22 spaces, so I need to count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I only have 9 spaces, and I know I need to be able to reach a height of at least 22. So I have some options. I probably don't want to go by 5s. That's going to squish my graph down too far. If I do 3 times 9, I would get 27, so that's plenty of space. So let's go ahead and count by 3's vertically. So 3, 6, 9, 12, 15, 18, 21. And then I can go by 1's along the x-axis. So my x-axis represents the number of triangles, and my y-axis represents the perimeter. And I would just graph each of my points. It's going to be a bit of an estimation because this grid isn't really sized very well for the particular problem. 4 comes up to 22. And we notice that that looks like it's basically a linear pattern. I can imagine drawing a line through those points. All right, looking at the next part of this, what to do notes. It says a photography application. The table shows the relationship between the number of photos you take and the amount of memory in megabytes left on your camera's memory chip. Is the relationship a linear function? Describe the relationship using words, an equation, and a graph. All right, so in a linear function, we have what's called a constant rate of change. In a constant rate of change, the change in y divided by the change in x is always the same because that's what constant means. So if I look at this, this is going up by 1, up by 1, up by 1. This is going down by 3, down by 3, down by 3. So no matter which pair of change in y over change in x I look at, it would always be a negative 3 divided by 1, or just negative 3. Because that rate of change is constant, this will be a linear relationship. So if we want to try to put this into words, it doesn't look like they gave us a very specific place to put this. We might say that we start with 512 megabytes of memory, and each photo uses up 3 megabytes. So that would be a verbal description of what's going on in this table. If I think of that for a graph, I could say that y, the amount of memory left over, starts with the 512 and subtracts 1 times the number of photos, or just x, the number of photos. Because when x is 0, we're not subtracting anything. We keep the number of the total megabytes. But if x was 2, then we're subtracting 2 times the number of, we're subtracting 2 for the photos, right? X would be 2. And so we would have 512. Oh, I need to take that back. We're subtracting 3 times the number of photos because we're losing 3 megabytes per photo. So 3 times 0 is just 0. So 512 minus 0 is still 512. But 1 times negative 3 is negative 3. If we add that to 512, we get the 509. So we need to remember that this constant rate of change is going to multiply the number of photos to give us the amount of memory left at any given time. And again, with this tiny little graph, we're going to have to do something with spacing. Now, I very rarely recommend breaking a graph. Breaking a graph is when you see that little zigzag on it. But with this one, we really won't be able to see the change if we try to use a scale that allows for 500 to fit on here. Because the change between these numbers is so small, but the numbers themselves are so big, the line would just look flat. We wouldn't see that it was decreasing. So I'm going to leave the scale on the x-axis alone, where x is the number of photos, and the x-axis is the memory that remains. By breaking the graph, we say that the scale at the bottom is not relevant, and we start the scale here. So we could start at 500, and this could be 501, 502, 503, 504. Oh no, I'm still running out of space. It looks like we're still going to have to go by 2s. So let's call this 500. This can be 502, 504, 6, 8, 10, and 12. That'll fit it on the screen. So what we're saying is that the scale is constant above the breaking point. So we're starting at 512, and we're coming down 3 with each photo that we take. And again, we can see that we have a linear relationship. Those points look like they lie on a line.